Hello class 10 students, I hope everyone is doing well. So welcome to lesson number 2 of this chapter, electricity. So আজি আমি ফাৰ্ষ্টতে ডিসকাস কৰিম Ohm's law. So 1827ত জাৰ্মান ফিজিচিষ্ট জৰ্জ সাইমন ওমে এটা ৰিলেশনশিপ উলিয়াইছিল কাৰেন্ট আৰু পটেনশিয়াল ডিফাৰেন্সৰ মাজত. Ohm's law gives relation between two electric quantities. So basically Ohm's law দুটা ইলেক্ট্ৰিক কোৱান্টিটিজৰ মাজত এটা ৰিলেশন দিয়ে. এতিয়া সোৱা এটো এটা সিম্পল সাৰ্কিট. এই সাৰ্কিটটোত এটো এটা সেল, এডাল কানেক্টিং ওয়্যাৰ আৰু এটা বাল্ব কানেক্ট হৈ আছে. এতিয়া আমি জানো যে সেলৰ ফাংচনটো হৈছে potential difference create কৰা. So the function of the cell is to create potential difference. So circuit এটা যেতিয়া potential difference থাকে তেতিয়া তাত electric charge flow হয়. So charge flow হোৱা মানে তাত current flow হোৱা. আৰু যেতিয়া circuitটোত current flow হয় তাত কানেক্ট হৈ থকা বাল্বটো গ্লো কৰে as you can see here. আৰু আমি জানো যে conventional currentৰ directionটো হৈছে positive to negative. Clear? So guys, now tell me, what do you mean by Ohm's law? So see the definition. Ohm's law states that the current I flowing through a metallic conductor is directly proportional to the potential difference V across its ends provided its temperature remains the same. So Ohm's law to hoise jetia edal metallic wire current to flow hoy tat thoka potential difference to logot directly proportional. Okay, tar mane potential difference to bahile current to bahibo. And it is vice versa, but the temperature to constant hobo laibo. Okay, now the length, area of cross section, temperature and material remain constant, but apart from this temperature the cross sectional area, length and material also remain constant. Clear? So etia Ohm's law mote potential difference is directly proportional to current. So a symbol to hoise proportional or symbol. Okay, so proportional or symbol to jetia ami electronole equalole convert korim tetia tat ami eta constant pam. So see here, V by I equal to constant and that constant is R. So metallic wire dalot at a given temperature R to hoise constant and it is called resistance. Okay, so we will denote resistance as capital R. So from here we got the formula V equal to I into R. Hence potential difference V equal to current into resistance. Clear? So this is known as Ohm's law. Okay, I hope everybody understood now Ohm's law. So tumalokor examination point of view pra Ohm's law to eta important law. So exam ot jodi define koribole ahe you have to write everything in detail. Am I clear guys? Okay, now let us see resistance. So resistance means to oppose or resist something. Okay, so in this case basically to oppose current. Now see, this is a metallic wire. So inside a metallic wire when atoms are more, resistance is more and current is less. So এই wireৰ ভিতৰত যদি atoms বোৰ বেছিকে আছে তেন্তে তাত resistance ও বেছিকে আছে. Okay, আৰু resistance বেছি হলে তাত current ও কম, current is less. But when atoms are less, resistance is less and hence current is more. So atoms বোৰ যদি কমকে আছে তাত তেতিয়া resistance ও কম আৰু resistance কম হলে in turn current is more. Okay, current ও বেছি. So the property of the conductor due to which it opposes flow of current is called resistance. So basically resistance to hoise conductor eta property jote current flow of current to oppose kore ba resist kore. Clear? So it resistance or SI unit to ki. So see here, the SI unit of resistance is ohm. So this is the symbol of ohm. So a ohm to hoise as resistance or SI unit. Clear? Etia ami jano je resistance or unit to hoise ohm, potential difference or volt aru current or ampere. So 1 ohm equal to 1 volt by 1 ampere. Now see here, if potential difference across two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance of conductor is 1 ohm. So etia eta conductor duta ends or jodi potential difference to 1 volt hoy aru tat 1 ampere current jodi flow hoy tetia he conductor resistance to hoise 1 ohm. I hope everybody understood now. Great. Now let us see the factors affecting resistance. So ite ki factors se resistance to affect kore. The first one is length. So dudal wire consider kora edal suti aru edal dighol, okay, of different length but same material, eke material hobo laibo. So এতিয়া দীঘল ৱায়াৰডালত ৰেজিষ্টেন্সটো বেছি হ'ব ওকে কাৰণ দীঘল ৱায়াৰডালত বেছি ইলেক্ট্ৰনছ অপ'জ কৰিব কিন্তু চুটি ৱায়াৰ হ'লে ইলেক্ট্ৰনছটো কম অপ'জ কৰিব সো চুটি ৱায়াৰডালত ৰেজিষ্টেন্সটো কম সো দিস ইজ হাউ দ্য লেংথ affects the resistance clear so jiman dighol length hobo himan besi resistance so in short we can say that R is directly proportional to L that means resistance is directly proportional to length now see the second factor that is area of cross section so ami jodi dudal pipe law edal khin aru edal hokot so kundal pipe edi pani tu easily flow hobo can you tell me definitely hokot pipe diledi right because khin pipe dalot obviously resistance besi hobo hokot pipe dalor comparison otke clear so here we can say that resistance is inversely proportional to area of cross section and the third factor is material the nature of material so wire dalor material to upor depend kore karon high resistance or material eta use korile quickly heat hoi jay aru joli jabo pare so ami low resistance or material use koru like copper karon low resistance or material bur easily heat hoi na jay clear our last factor to hoise temperature so iti ami first factor to par gom palu je R is directly proportional to L so length to jodi barhe resistance to bahibo okay so itu bahile hitu komile hitu komibo am I clear our second factor to ami gom palu je R is inversely proportional to area of cross section so let us see how if the door is wider more people can enter resistance is less so picture to swa tomaluke door khonor width to jodi besi hol hoy tetia tat aru manu humabo parilheten karon tat resistance to kom right so if wire is thicker more electrons can flow as resistance is less so edal hokot pa thik wire electrons to besike flow kore karon tat resistance to kom hence you can say R is inversely proportional to area of cross section clear so iti ami e duta combine kori a formula to pam R is proportional to L by A so iti ami jodi a proportional to equal hole convert koru eta constant pam he constant to hoise rho and this is the symbol of rho okay so resistance equal to rho into L by A now the unit of resistivity is so let us find the unit rho equal to R into A by L so we know that resistance unit is ohm area it is meter square and length it is meter so we will get the SI unit of resistivity is ohm meter clear okay guys tumalike unit bilak monot rakhiba karon numericals pur korute ami unit to likhibo laibo okay while solving it because unit to jodi tumalike nilikha marks can be deducted okay so keep that in mind now let us see the practical understanding of resistivity so it is a circuit and this circuit is not a complete circuit okay as you can see here it is a broken circuit so these are the cells combination of cells or battery you can say a switch and a ammeter eti ami janu je ammeter to hoise eta instrument which is used to measure current right so etia a gap tut ami first sote copper wire di join korim so when we joined the gap between A and B with a copper wire we saw that this ammeter it has changed from 0 to 30 okay so that means we can say that there is current flowing in the connecting wire now replace this copper wire with an aluminum wire again we can see that there is a change in the aluminum so again we can say that current is flowing but now replace this aluminum wire with a glass rod we can see that there is no change in the ammeter okay again replace this glass rod with a rubber again we can see that there is no change in the ammeter that means no current is flowing when rubber and glass rod was connected between A and B so those are bad conductors or you can say insulators okay so insulators like rubber and glass have resistivity of the order of around 10 to the power 12 to 10 to the power 17 ohm meter okay but this copper and aluminum wire they are good conductors of electricity and copper it has resistivity around 1.62 into 10 to the power minus 8 ohm meter and aluminum it has around 2.63 into 10 to the power minus 8 ohm meter Clear? So from here we can say that resistivity is a specific property of a material. Okay, এতিয়া maximum studentsৰে হয়তো এটা ডাউট বা কনফিউজন থাকে বহুতে ভাবে যে ৰেজিষ্টিভিটি আৰু ৰেজিষ্টেন্স দুইটা একে বা দুইটা একে নহয় দুইটা বেলেগ বেলেগ কাৰণ ৰেজিষ্টেন্সটো হৈছে কাৰেণ্টক অপ'জ কৰে বা বেসিক্যালি এটা ডিভাইস ওকে কিন্তু ৰেজিষ্টিভিটি এটো হৈছে এটা মেটেৰিয়েলৰ স্পেসিফিক প্ৰপাৰ্টি ওকে সো ৰেজিষ্টিভিটি টো প্ৰপাৰ্টি হে এটো এটা ডিভাইস নহয় বাট ৰেজিষ্টেন্স টো এটা ডিভাইস So don't get confused between resistance and resistivity. I hope you are clear now. Great. Now see the second point. Different materials have different resistivity. So already I mentioned korisilu beleg materials or resistivity beleg. And silver, it is a very good conductor of electricity which has resistivity 1.6 into 10 to the power minus 8. Clear? Alright, now let us see question number 1. On what factors does the resistance of a conductor depend? It's an easy question. Yes, the resistance of a conductor depends on its length, area of cross section, that is thickness, material, and temperature. So these are the factors which depends, Alright, now move to question number 2. How does the resistance of a wire change when its length is tripled, its diameter is tripled, its material is changed to one whose resistivity is 3 times. Okay, now pause the video for a minute and try to solve it by yourself. Alright, now see here, R equal to rho into L by A. We know that, right? So for A, if its length is tripled, so iti ami janu je resistance to length or logot directly proportional. Jodi length to barhe, resistance to barhibo, and it is vice versa, right? So যদি length to triple হয় then definitely resistance to triple হ'ব. Therefore if length is tripled, resistance is also tripled. So guys, now see here, this is the solution. So diameter to যদি tripled হয়, we can write it like this, right? D equal to 3D. আমি জানো যে resistance equal to rho into L by A. So area equal to pi r square, we can write it like this. Now can we write radius equal to D by 2 whole square? Of course, right? So keep it like this. Now r dash equal to rho into L by pi. Now replace this D with this 3D because we know that diameter equal to 3D because it has been tripled. So 3D by 2 whole square, we will get 1 by 9 rho into L by pi D by 2 whole square. So it is A term to or A term to AK, right? From here we will get resistance equal to 1 by 9 times. Okay, so diameter to jodi triple hoy, resistance to 1 by 9 times hobo. Okay, let me clear this. Now see question number C. When its material is changed to one whose resistivity is 3 times. So wire material to change korile jar resistivity to 3 times tetia he wire resistance to kiman hobo. So resistance aru resistivity relation to ki? Ami jano je resistance is directly proportional to resistivity. So resistance barhile resistivity barhibo aru resistivity barhile resistance barhibo. Therefore, if resistivity is tripled, resistance is also tripled. So jihetu eta resistance aru resistivity they are directly proportional to each other. Therefore, resistivity to jodi tripled hoy, definitely resistance to tripled hobo. Clear everyone? So it was a easy question, right? Now moving to question number 3. Will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source, and why? So it is jodi ami dudal wire law of same material, edal thick or edal thin, okay, and they are connected to the same source. So it is current to kundal wire did easily flow hobo through the thick wire or the thin wire. So see the answer. When connected to the same source, current will flow more easily through the thick wire than the thin wire. So same material jodi hoy aru same source jodi connect hoy thake tetia current to thick wire di easily flow hobo. And this is because resistance is inversely proportional to area of cross section. Ami janu je cross sectional area to jiman dangor hobo himan resistance kom hobo aru resistance kom hole current besike flow hobo ba easily flow hobo. Clear? Now see, this is a circuit of television. So TV eta ami khulile tar bhitorot circuit dekha pam. Eta circuit etat ki thake? Ami janu je circuit etat cells বা battery, switch or plug key, connecting wires আৰু বেলেগ electrical components. Now as you can see here, this looks very complicated, right? So to make drawing of circuits easy, let's learn electrical symbols. So circuit or schematic diagram to draw koribole besi convenient, right? So circuit etar electrical components bur ami kisuman symbol represent korim conveniently draw koribor karone. Alright, now let us see the electrical symbols. So the first one is cell, and this is the symbol of a cell. Next is battery, and this is how we represent battery. So guys, now can you tell me what is the difference between cell and battery? Yes, we know that battery is a collection of cells. So don't get confused between cell and battery. Next is keys or switches. So this is how the plug key looks like, and this is the symbol of plug key when it is on, and this is how it looks like when it is off. So see the difference between on and off. Now see switches. So this is the symbol of a tab key when it is on, and this is the symbol when it is off. Next is resistance. So already I mentioned korisilu je resistance to hoise eta device. So resistance to dekhibole enekwa, and the symbol of resistance is this. Okay? Now see variable resistance. So variable resistance or symbol to hoise etu. Next is variable node resistance. So this is how we represent variable node resistance. So guys, now variable node resistance to hoise voltage source to change no korake current regulate kora eta component. Clear? Now see measuring instruments. So first one is ammeter. So ammeter is an instrument which is used to measure electric current in a circuit. So this is the symbol of ammeter. Next is voltmeter. So this is how we represent voltmeter. So voltmeter is also an instrument which is used to measure potential difference. Clear? Now see galvanometer. So this is how we represent galvanometer in a circuit. So this galvanometer, it is also a device which provides information about the magnitude and direction of current. Clear everyone? Now see here a wire joint. So this is the symbol of a wire joint. Now see this is the symbol of a wire crossing. So dudal wire jetia cross hoy, this is how we represent. And now see last one, this is the symbol of an electric bulb. Clear? So it's test time. Now draw the symbols of components required to make the circuit. Okay guys, now pause the video for a minute and try to draw the symbols, okay? So I guess everyone is now familiar with the electrical symbols. Okay, great. So now let us see some important points to remember. While connecting cells to each other, always connect unlike terminals. So আমি যেতিয়া সেলসবোৰ কানেক্ট কৰিম তেতিয়া আমি সদায় পজিটিভ নেগেটিভ এ কানেক্ট কৰিব লাগিব ওকে দ্যাট মিন্স we should always connect unlike terminals. Am I clear? Now see here, for devices like ammeter or voltmeter, the side from which current enters is positive and the side from which current exists is negative. So devices like ammeter or voltmeter, so a device brought current to positive edi humai negative or pra ulai jay. Okay? Now see some more important points. So this is a circuit, and basically this is a series circuit. Okay? So series connection. Etia series circuit ot current flow hobor karne okol eta pathe ase. As you can see here, this is the only part. So he karne current to different branches purot divide hua nai. As the current in the circuit is not divided, ammeter is connected in series with the cell. So jihetu current to circuit divide hua nai, he karne ammeter to cell or series connection ot ase. As you can see here, ammeter it has very low resistance, so it allows almost entire current to pass. So etia ammeter resistance bahut kom. Ami jano je resistance kom hole current besi flow hoy. So it does not disturb the current as well as measures the current. So this ammeter, it does not disturb the flow of current or it does not oppose the current and thus measures the current. Clear? Etia soa etu eta parallel circuit. So parallel circuit on eta pathot ke besi path available ase. Can you see here? So current do split ba divide hoi jay between multiple paths. As the current in the circuit is divided, voltmeter is connected in parallel with the cell. So jihetu parallel circuit ot current to divide hoy, he karone voltmeter to cell or parallel connection ot ase. Can you see here? Now see voltmeter, it is made from a material having infinite resistance. So it a voltmeter to enekwa materiality bonwa hoise jot infinite resistance ase. Okay, so the current it allows is negligible or almost zero. So he karne voltmeter to jehetu bahut resistance ase, infinite resistance ase, he karne voltmeter di current flow hobo nware. Okay, now see question number 1. How is a voltmeter connected in the circuit to measure the potential difference between two points? So duta points or potential difference to measure koribor karne voltmeter to ami circuit ot keneke connect koribo laibo. So see the answer. To measure the potential difference between two points, voltmeter must always be connected in parallel to the points. So ite duta points or potential difference to measure koribor karne voltmeter to ami hodai parallel connection koribo laibo. Okay, parallel to the points. Alright, now see question number 2. What happens if an emitter is connected in parallel? So emitter to ami series ot connect nokori jodi parallel ot connect koru tetia ki hoy soa. If an emitter is connected in parallel, the resultant resistance of the circuit decreases and more current passes through the emitter. Hence the emitter is likely to be burned. So emitter to ami series ot connect nokori jodi parallel ot connect koru tetia circuit ot thoka jonto resultant resistance he resistance to komi jabo. Aru ami janu je resistance komar loge loge current to bahi jabo. Aru current to jetia emitter di flow hobo tetia he emitter to joli jabo pare, because there will be more current flowing in the circuit. Clear everyone? Aru he karone emitter to hodai ami series ot connect koru, not in parallel. Okay, now moving to question number 3. What happens if a voltmeter is connected in series? Etia ami janu je voltmeter to parallel ot connect koru, right? But parallel ot connect nokori jodi series ot connect koru tetia ki hoy soa. When the voltmeter is connected in series, the resistance of the circuit becomes high and there is considerable fall in current through the circuit. Thus the voltmeter will not give the correct reading of the potential difference. So voltmeter to jodi ami series ot connect koru tetia circuit ot thoka jotu resistance he resistance to bahi jabo. Our resistance bahar loge loge current to komi jabo. Okay, and thus the voltmeter it will not able to provide us the correct reading of the potential difference. Clear everyone? Now let us do one experimental verification of Ohm's law. So ami janu je Ohm's law mote V is directly proportional to I. That means potential difference is directly proportional to I. So from here we get the formula V by I equal to R. R it is constant, which is also called resistance. So a activity to ami edal nichrome wire lom of length 3 meter and diameter 0.02 centimeter. So now set up a circuit consisting of nichrome wire, an emitter, a voltmeter and cells. Okay, etia nichrome to hoise eta alloy of nickel, chromium, manganese and iron metals. Clear? Etia soa circuit or source to ami first tote eta cell connect korim. Okay, now note the reading in the emitter for the current and note the reading of the voltmeter for the potential difference. Okay, so ami current to pam 1 ampere, potential difference 2 volt aru resistance to 2 ohm. Next ami duta cell connect korim circuit tot tetia ami current or reading to pam 2 ampere, potential difference is 4 volt aru resistance to 2 ohm. Etia ami upor duta step ako repeat korim. Etia circuit tot ami tinta cell connect korim. Etia current to hoise 3 ampere, potential difference to 6 volt aru resistance to 2 ohm. So etia ami V by I ratio to calculate koribo laibo. Clear everyone? So now plot a graph between V and I and then we have to observe the nature of the graph. Okay, so potential difference V to ami x axis ot lom aru current I to ami y axis ot, and this is the origin O. So guys, etia a activity to tinta kesote ami dekhisu je V by I value to same. Can you see here? Okay, now plot the values in the graph. After plotting we can observe that V by I graph to adult straight line. Can you see here? Which passes through the origin of the graph. So thus we can say that V by I is a constant ratio. So jehetu graph dal straight line ami kobo paru je V by I to hoise eta constant ratio. Clear everyone? So etia এই ষ্ট্ৰেইট লাইনডালে শ্ব' কৰিছে যে ৱায়াৰডালত যেতিয়া কাৰেণ্টটো ইনক্ৰিজ হয় তেতিয়া সেই ৱায়াৰডালৰ পটেনচিয়েল ডিফাৰেঞ্চটো ইনক্ৰিজেছ লিনিয়াৰলি ক্লিয়াৰ চ' দিছ ইজ কল্ড Ohm's law. I hope everyone understood now. So guys, we are done for lecture number 2 and if you have any doubt you can comment us. Thank you.